Show a full worksheet of Matrices exam style papers. Very, 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 very easy. All right. So, of course, with matrices, what you need to focus on are the operations of matrix: addition, subtraction, multiplication. And you should be able to find the adjoint of a matrix. You should be able to use a matrix method to solve equations. You should know about singular matrix, non-singular matrix, adjoint of a matrix. Those are all that are on the CSEC syllabus, and that is what we'll be doing today. So I tell you that if x is minus 2, 0, 5, 1, so they give you this matrix. This is x. X is minus 2, 0, 5, 1. And then they give us another matrix y, and they tell us that y is equal to 4 minus 1, 3, 7. And then this is what the question asks us. They want us to find 2x minus y, x squared, and xy. So we have three things to do. We need to find 2x minus y. So to find 2x minus y, what we're going to have to do is multiply all the elements inside of x by 2. So that would be equal to 2 times all the elements inside of x. So it's 2 times minus 2, 0, 5, 1. And then we subtract the matrix y, which is this right here. 4 minus 1, 3, and 7. So what we're going to get is, when you multiply everything in this by 2, what we're going to get is 2 times minus 2 is negative 4. 2 times 0 is 0. 2 times 5 is 10. 2 times 1 is 2. Then you close up that right there. Yeah, man, it's that easy. And then we subtract now matrix y, which is 4 minus 1, 3, and 7. So now when you subtract elements of matrix, you have to make sure you subtract corresponding elements. So it's going to be minus 4, and that becomes minus 8 right here. Then the element in the first row, second column right here is 0, minus, minus 1. This minus and this minus make it become plus, so this becomes 1. Then it's 10 minus 3, which make it become 7. Then 2 minus 7 becomes minus 5. So that would be the answer, minus 8, 1, 7, minus 5. That's how we find 2x minus y. The next thing it wanted, part B, was it asked us to find the matrix x squared. To find the matrix x squared is equal to x times x. That's how you find the square. You multiply something by itself. So don't go and square all the number in here. So x squared is the matrix x times x. So you have minus 2, 0, 5, and 1. And then what you do is you multiply it by minus 2, 0, 5, and 1. When you multiply them across now, it's going to be row by column. So what's going to be is this, minus 2 times minus 2. When I put a bracket, the bracket means multiplied. So it's minus 2 times minus 2, row by this column, then plus 0 times 5. That's going to be the first element in the matrix. Then it's going to be over here, row by column, minus 2 times 0 again. plus 0 times 1. That's what's going to be right there. Close up that. Element right here now is this row by this column. So it's going to be 5 times minus 2. So this row times this column, this times this, then plus 1 times 5. Then you got this row by this column, that's now 5 times 0. Then you have plus 1 times 1. That's what you do right there. So what this works out to be now is, as you can see, this, when you expand this, minus 2 times minus 2 is 4. Then 0 times 5 is 0. Minus 2 times 0 is 0. 0 times 1 is 0. 5 times minus 2 is minus 10. Minus 10 plus 5 is still 5. And then this right here is 5 times 0 is 0, plus 1 times 1 is 1. So we end up get 4051. That's x squared, 4051. All right. So let's do part C up here. Maybe not enough space for part C, but let's try and do it right here. Part C was asking us for x times y. To find the matrix x times y, we're multiplying these two matrices now. So it'd be multiplying minus 2, 0, 5, 1. Notice that x have to come first. Write down x first since it's x times y. Multiplied by 4, minus 1, 3, and 7. So multiply these two matrices again. It's going to be row by column, this row by this column. So it's going to be negative 2 times 4 plus 0 times 3. That's what we're right there. Then the element for this row and this column now is going to be negative 2 times negative 1. Then you have 0 times 7, so plus 0 times 7. Cool. They will come down here now, and what it's going to be is this row by this column, so it's going to be 5 times 4. Then you have plus 1 times 3. Over here now is this row by this column, so it's 5 times minus 1. Then you have plus 1 times 7. And that's it. Nice. Finish it off right here. This is minus 8. This right here is minus, and minus become plus, so that's positive 2. This is then 20 plus 3, that's 23. And then this right here is 7 minus 5, which is 2. That's the matrix x times y. So that's how you do this question right here. Not very difficult, very easy. All right, nice. That takes care of question 1. Nice. All right, so we did the first question right here. Now, let's look at this second one right here. It says calculate the matrix product A times B. All right, so calculate the matrix product A times B, and A is this matrix, B is that matrix right here. Let's see if we have enough space right here. So if we're working out A times B, this is part A times B, we're just multiplying 3, or let me make the space a little bit smaller. 3, 5, 1, 0, and we multiply it by matrix B, which is 6, 4, minus 1, minus 2. Again, we apply the same principle. First row by first column to give us the first element in the matrix AB. So row by column, 3 times 6, and then plus 5 times minus 1. To get the element in the first row, second column, it's this row by this column. So it's going to be 3 times 4. 3 times 4. Then plus 5 times negative 2. 5 times minus 2. Cool. Then down here now, first row, well, second row, first column is 1 times 6 plus 0 times minus 1. And then this row by this column is 1 times 4. Then you have plus 0 times minus 2. And that's it. All right, so what this works out to be is that the matrix A times B will work out to be, this is now 18 minus 5, which is 13. Then this one is now 12 minus 10. 12 minus 10 is 2. Then we have 6 plus 0 is 6. 1 times 4 is 4, plus 0 times minus 2 is 4. That's the matrix AB. All right, cool. Now this question says now if C is this right here and 2A plus C is AB, find the values of X and Y. So first thing, let us write down A. So recall that A is the matrix they give us, and they told us that A is 3, 5, 1, 0. This is a matrix A. And then they give us this new matrix C, and they tell us that this matrix C is equal to X minus 8 for Y. All right, what else did they tell us? So let's look back at it now. They also told us that 2A plus C equal AB, where we found AB is 13,264. So let's write down our AB, 13,264. All right, nice. So wrote down AB. Now, next thing they tell us to do is find X and Y such that 2A plus C equal AB. That's what they told us. 2A plus C is equal to AB. So what does that mean? That implies that 2 times the matrix A, which is 3, 5, 1, 0, plus the matrix C, and C is X minus 8, 4 and Y is equal to A times B. So it's equal to, this is A times B, 13, 2, 6, and 4. So then what are we going to do? What we're going to do now is simplify the left-hand side, multiply everything in here by 2. 2 times 3 is 6. 2 times 5 is 10. And then we go 2 times 1 is 2. 2 times 0 is 0. So this is 2 times A. Then we add it to matrix C. But matrix C is just X minus 8 for Y. Yeah, man. So come simplify this left-hand side before we look at the right. So now we're going to go 6 plus X to make this become 6 plus X. Then we're going to have 10 plus minus 8. 10 plus minus 8 is just 2. Then 2 plus 4 is 6. And then 0 plus Y is just Y. All right. And so all of this over here now is 2A plus C. And remember that 2A plus C is equal to AB. So we can just equate that side now to AB. So let's write that down. It's equal to 13, 2, 6, and 4. All right, nice. Now it says now we need to find Y. Now notice, if you look at this, the 2 is equal to the 2. The 6 is equal to the 6. And so what do you need to do? This y right here is equal to this 4 right here. So what does that mean? What that means is then y is equal to 4 because we can equate corresponding elements. So y is equal to 4. Now right here, so now if you look at this, you have 6 plus x in the first entry in this matrix, and the first entry in this matrix is 13. So that means that 6 plus x must equal to 13 since both matrices are equal. And so we can conclude that x must be 13 minus 6, which is 7. X has to be 7. 6 plus 7 is 13. So those are your answers. X equals 7, y equals 4. Nice. So that would go right here. X equals 7, y equals 4. All right. Now this one is a little bit different. So this third one here, it tells us that t is minus 2, well, 2 minus 3, 1, 2, and g is minus 2, 3. Calculate the matrix product tg. So let's write them down. So we have t is the matrix. That's 2 minus 3, 1, 2. And then we have the matrix G. And the matrix G was, what's that, 2, 3? Let's look back. Let's go back and see. I think it was 2, 3, minus 2, 3. I'll need to multiply to get t times g. So let's change the color under this. So to multiply t times g now, remember our multiply matrix, it's row by column. So first thing, just write back the product of the two. 2 minus 3, 1, 2. That's to write out t. Then write g side it in column matrix form, minus 2, 3. So now to multiply t times g, it's row by column. So this is going to be equal to 2 times minus 2. Then you have plus minus 3 times 3. Close up that. And then the element that goes down here now is row by column, which is 1 times minus 2. Then you have plus 2 times 3. All right? And that's how you multiply this right here. Now, first thing, remember, this matrix T have 2 row and 2 column. So it is a 2 by 2. This is a 2 by 2 matrix. This matrix G right here has 2 row and 1 column, right? But the number of columns of the first matrix must be equal to the number of row of the second matrix. And so that's how we end up going to get a 2 by 1. So it end up being compatible. So t times g works out to be 2 times minus 2, which is negative 4. Then minus 9, that's minus 13. And then we have 2 times 3 is 6. 6 minus 2 is 4. So tg is minus 13, 4. That'll be the matrix product of t times g. All right. So now that's that out the way. It says, given that AB is this, determine the value of A and B. So it's the same thing like the first one right there. All you have to do is multiply row by column. Row by column, 2 times minus 3, minus 6, plus. Then you just go 3 times 1, 3. Then the second row by the second column, minus 1 times minus 3, that's 3, plus 2 times 1, 2. So we end up get that this is minus 6 plus 3 is minus 3. And then 3 plus 2 is 5. So that's minus 3, 5. Now remember, minus 3, 5 is equal to the matrix AB. So now you can equate corresponding elements. So A, that implies that A equal negative 3, and B equal 5. That's all. A equal -3 and B equal 5 by equating corresponding elements. All right, question 5. Question 5 says the matrix A times B is equal to C, and it says determine the value of X. All right, so let's determine the value of X. So first thing we need is A times B. So let's write down those. So the matrix A is given by, look back at it, this is matrix A, 2, 1, minus 3, 4. That's the matrix A. Matrix B was given by X4. And then they gave us matrix C, I believe. Let's look back at it. They gave us matrix C, which is 12x, and then they tell you that A, B is C. So and they also tell us that C is 12x, and AB is equal to C. So find X. In a case like this, all you're going to do is, this is AB, so you have matrix A times matrix B is equal to C. So now this is matrix A, so we have 2, 1, minus 3, 4, and this is multiplied by matrix B. Matrix B is X, 4, and it's equal to matrix C, which is 12x. That's what we have right there. So since this is what we have right here, all we have to do is multiply row by column on the left-hand side. So we get 2 times x is 2x plus 1 times 4 is 4. That's how you get the first element in the matrix AB. Yeah, man. So that's how we get the first element in the matrix AB. Now we need to get the second element, which is going to be row by column. Minus 3 times 4 is minus 3x plus 4 times 4 is 16. And remember, this matrix here is equal to 12x. So you can use any one of these now to solve for x. If you wanted to equate the first, you want to equate the elements in the first row, first column, then you'd have 2x plus 4 is equal to 12. And so you'd end up have 2x is equal to 8. And so you'd have x equal 4. Let's say you wanted to use this equation. You would have minus 3x plus 16 is equal to x. You'd bring over the 3x over here to get 16 equal 4x. Then you divide both sides by 4 to get, if you divide both sides by 4 now, you get 4 is equal to x. So anyway you take it, x equal 4. That's it. So this one rounded down to x being 4 for number 5. All right. Now number 6. Number 6 says determine 3 times A. Then to determine B inverse, then that 3, A plus B inverse, then find the values of A, B, C. If 3A plus B inverse is C. So let us do this question, but first we're going to have to write down A, B, and C. So A is given by the matrix with no actually known elements given. It's just given by A, B, C, D. That's what they give us for A. And then they want us to find B inverse, and B is 5, 3, 3, 2. B is 5, 3, 3, 2. Nice. This is A, this is B. And then they give us C, which is 14, 0, minus 9, 5. 14, 0, minus 9, 5. That's C. All right, nice. Let's see now. So now they say find 3 times A. That's the first one, part A. 3 times A. So of course, that's pretty easy. We just multiply all the elements of A by 3. So we can just write that this is 3A, 3B, 3C, 3D. All right, so that's the matrix 3A. Next thing we need to work out is this one now, which is B inverse. So the next part now, part B, wanted us to find B inverse. To find B inverse, the first thing we need to do is find the determinant of B. The determinant of B, so remember, B inverse is equal to 1 over the determinant of B. You see this slash symbol times the adjoint of B. That's how we're going to find B inverse. The determinant of B is going to be the product of the leading diagonals. So it's 5 times 2 minus the product of the non-leading 3 times 3. That's how we find the determinant. And then this is being multiplied by the adjoint. To get the adjoint, you switch these two elements, switch their places in B. So the 2 come up here and the 5 come down here. And then you negate. When I say negate, I mean multiply by -1. You multiply elements B and C by -1. So here will become -3. Here will become -3. So that is B inverse. B inverse is now just 5 times 2 is 10. Minus 3 times 3 is 9. 1 over 1. So we get 1 times, this is 2 minus 3 minus 3, 5. So that's B inverse. Then part C said now to find the matrix 3A plus B inverse. So to find 3A plus B inverse, all you're doing is adding these two matrices. So you're adding 3A, 3B, 3C, 3D. You're adding that to 2 minus 3 minus 3, 5. Yeah, man, that's all we're adding. So we'll add these two matrices. What we're going to be getting is 3A plus 2 is 3A plus 2. Then we add 3B minus 3, that's 3B minus 3. Then right here, so now you have 3C plus minus 3, that's 3C minus 3. And then you have 3D plus 5. All right, nice. So good. So we'll find 3A plus B inverse. All right, nice. Now when you look at this now, it says find the value of A, B, and C since 3A plus B inverse equals C. So in order to set up that equation now, right, you have 3A plus, well, let me not start right there. We just want to start with the fact that 3A plus B inverse is equal to the matrix C. It's equal to the matrix C. Now what is 3A plus B inverse? If 3A here plus B inverse is equal to that. So we have that this side is 3A plus 2. Right here was 3B minus 3. Right here was 3C minus 3. Right here was 3D plus 5. And all of this is equal to now matrix C. Matrix C is given by, let's look back at it. This is matrix C, 14, 0, minus 9, 5. 14, 0, minus 9, 5. So to find A, B, and C, all you have to do is equate corresponding elements. So that means that 3A plus 2 is equal to 14. And so if we subtract 2 from both sides, 3A equal 12, and so A equal 4. Nice. Now this side right here, now we have 3b minus 3 equals 0. And so we end up get 3b equal 3. And so we end up get b equal 1. Nice. Then right here, so now we have 3c minus 3 equal minus 9. And so we have 3c equal, add minus 3 to both sides. Minus 9 plus minus, well, minus 3, add 3, that's positive 3, that's minus 6. And so c equal negative 2. Then finally, right here, so now you have 3d plus 5 equal 5. And so d must be 0, because then 3d equals 0, and so d equals 0. And that's it. A is 4, b is 1, c is minus 2, d is 0. That's it. Soft. So we did this one right here. To find the values of a, b, and c, we end up get a equal, what was that again? 4. We end up get b equal, what was that again? I think it's negative 2, b equal 1, negative 1, we get c equal 2, and d equals 0. Determinant of the matrix M, and this is M. Remember, the determinant symbol is this right here. That means determinant of M. The determinant of M is the product of the leading diagonals, that would be 2x, minus the product of the non-leading, which is 3 times minus 1. Minus 1 times 3 is minus 3, but minus and minus become plus. That works out to be 2x plus 3. 2x plus 3. Then it says, given that m is singular, calculate the value of x. If m is singular, what that means is that the determinant of m equal to 0. Determinant of m equals 0 if m is singular. And so what you do then is you set 2x plus 3, which is the determinant, equal to 0. So that would mean that 2x is equal to negative 3, and so x is equal to negative 3 over 2, or negative 1.5, that is x. This question here, it says determine determinant of n. Again, you multiply product of the leading diagonals, 4 times 3 is 12, minus product of the non-leading, 5 times 2, which is 10. So we end up get 12 minus 10, which is 2. Then it says calculate n inverse. Remember how we find inverse? The inverse of a matrix, n inverse, is 1 over the determinant times the adjoint. 1 over the determinant of n times the adjoint of n. Now what is the determinant? The determinant of n is, let me put determinant. Determinant of n is 2. So n inverse is 1 over 2 times the adjoint of n. And the adjoint of n is, we interchange the leading diagonal. So we interchange the 4 and the 3. Put the 3 where the 4 is and put the 4 where the 3 is. Then we negate the non-leading diagonal, meaning we multiply the non-leading by negative 1. So that's what we do. So this would be n inverse. Then it says, show by calculation that n times n inverse equal I. Remember what is I? I is the identity matrix, and the identity matrix is 1, 0, 0, 1. 1, 0, 0, 1. So this is what we need to show. So first thing we're going to do is let's write down this on the whiteboard here. So we're going to write down that n is the matrix given by, what was n again? N was 4, 2, 5, 3. That is n, 4, 2, 5, 3. And then write down what n inverse was. N inverse was 1 over 2 times the matrix 3, 4, minus 2, minus 5. So to multiply n times n inverse, this is all we're going to do. N times n inverse is equal to, first thing I like to do is factor out the half. So put the half right here, put the half right here, and then work out 4, 2, 5, 3 multiplied by the adjoint of n, which is 3, -2, -5, 4. We'll multiply this across now. We get a half times, remember it's row by column. Row by column. 4 times 3, 12, plus 2 times -5, that's -10. Then over here it's going to be 4 times -2, -8, plus 2 times 4, which is +8. Then this row by this column is 5 times 3, which is 15. Then plus 3 times -5, which is -15. Then you have row by column, 5 times -2, -10, plus 3 times 4, which is 12. So n times n inverse works out to be equal to a half of 12 minus 10 is +2, -8 plus 8 is 0, 15 minus 15 is 0, -10 plus 12 is 2. So when you multiply everything by a half now, you get 1, 0, 0, 1. But 1, 0, 0, 0, 1 is the identity I. So therefore, n times n inverse is I. All right? Yeah. Nice. So that's it. We showed that n times n inverse was equal to I. All right? Nice. So the first one right here says, evaluate the determinant of A. That's quite easy. So we know that the determinant of A, that is just product of the leading, 3 times -3, minus product of the non-leading, 2 times 2, right?
Yes, sir.
So that's just -13. Good. So now it says, hence we're supposed to determine the inverse. So to determine the inverse, well, let's do it on the white screen. So we need A inverse, but to find A inverse, we know that it is 1 over the determinant of A, right?
Yes, sir.
Multiplied by the
Adjoint.
adjoint of A. Very good. Multiplied by the adjoint of the matrix A. All right. Then let's look back at what was A. A was 3, 2, 2 minus 3. Let's just put A right here. A is 3, 2, 2 minus 3. All right, so to find A inverse now, we already established that the determinant is 13. So it's just now 1 over 13 times the adjoint of A. The adjoint again, we switch the leading and the non-leading. So we'll put the -3 where the 3 is, and we'll put the 3 where the -3 was. Then we negate the non-leading. The non-leading again are these two. So we put a -2 here, a -2 here. Negate means multiply by -1. So that is A inverse. All right. So that's the second part. We call it this?
Yes, sir.
All right. Now it says, hence we're supposed to, using A inverse, solve the equation 3x plus 2y equal 1 and 2x minus 3y equal to 5. So we're supposed to solve, let's just write it down. 3x plus 2y equal 1. And we also need to solve 2x minus 3y equal 5. So when it says solve using a matrix method or using A inverse, what we have to do is write this in matrix form. So really we're solving, you write down the coefficients of the x and y in the matrix form. So you always try to write it in the form ax equal b. So in this first column here, we put the coefficients of the x, 3 and 2. Then in this column right here, we'll put the coefficients of y, which is 2 and negative
-3.
3. Good. Then this column right here is just going to be our
XY.
x and y or unknown matrix. Good. Then we equate it to the result matrix, which is 1, 5.
5.
Nice. So of course, using the inverse method, what we know is that the inverse will end up give you that. You see xy is going to be equal to A inverse. This is A inverse. This is A inverse up here. It's going to be equal to A inverse times the matrix B, the result matrix. So xy is going to be equal to 1 over 13 times the adjoint, which was -3, -2, -2, 3. And then this is multiplied by the result matrix of 1, 5. All right?
Question.
Yes.
So in the exam, right, we already know to get x and y values is the inverse of the first matrix. Do you get marks? Do you lose marks, I should say, if you just skip straight to the inverse?
If you don't write this line?
No, not if you don't write like the second part.
This part right here?
Yeah, like if you don't include that, like once you times it.
If you don't include this part, you lose marks. You have to put down this.
Also, not that part. That
Okay.
first part, like when you times it by together. When you're first doing it and we had to times it by itself.
Oh, I
What you
don't
do
get
to
what you
one,
mean.
what you do to one side, you do to the other.
Oh, no, you don't have to put that step. No, no, no. I get what you're saying now. Oh, you're saying that when we get it in this form, ax equal b, you're saying you don't have to pre-multiply to show them that part. No.
Okay.
All right.
Fine.
No. We're going to have to tell them after you. And you don't even have to pre-multiply. And as I said, they could have rewritten it as this way where you divide both sides by a and x. Divide both sides by a. But then you can't be doing division in matrix. So this would end up work out to be that x is 1 over a times b. But 1 over a is a to the -1 times b. So yeah, you don't need to put this step in it.
Okay, so I don't need to
Alright.
say that the thing by its inverse is the identity matrix. I don't need to say that.
No,
Okay.
no. You just need to jump from here to here.
Okay, sir. Thanks.
All right, nice. So now we can finish this off now. So it's gonna be 1 over 13 times. We just multiply this row by this column. So we have -3 times 1, that's -3. Then we have plus -3 times 5, that is -10. And then this row by this column, that's -2 plus 15. So we'll finish and work it out. What we're gonna get is xy is 1 over 13 of, this looks like -13, +13. And so that is gonna then tell us that when we multiply this column matrix by 1 over 13, we get what we get?
On -1, 1.
-1, 1. Beautiful. -1, 1. So that's what we get for our answer. So finally, you can write down and tell them that solving it using matrix method, we get x equal -1 and y equal to 1. Now, just to check it, it's always good when you check it. 3 times -1 is -3 plus 2 times 3 times -1 is -3 plus 2 times 1. That's not 1. That's -1, don't it?
Oh, yes, sir.
Oh, I wrote down the determinant was -13. My apologies. -13.
Oh, so it's 1 over -13.
Yes, now 1 over -13. -13 should have been here.
Okay.
-13 here. -13 here. That would have made this x
1,
positive 1.
-1.
and then y is negative. Thank you.
Mm-hmm.
Yes, so y is negative. All right, so it's good that we pay close attention there. We almost gave it away. So we can edit this and put that x is the positive one and y is the negative one. Now it makes sense. 3 minus 2 is 1. 2 times 1 is 2. Minus 3 times minus 1 is positive 3. 2 plus 3 is 5. Good. It's not that different. So let's look at question 3 now, and then you're going to take on question 4, which is similar to question 3. Notice it starts similar, evaluate inverse, hence or otherwise determine the values of A, B, C, D. All right, it's very similar. All right, so all right, so we can do this one right here. Find the inverse of this, write it down. So before we can write it down, right, I'm just gonna call it matrix M, just to call that M right there. So the determinant of M is gonna be?
1 minus 8.
Very good, 1 minus 8, which is negative 7, good. So now we can just write down the inverse of M and tell them that M inverse, because that's what they said, they said write down, so we shouldn't show a bag of calculation. M inverse is 1 over the determinant, 1 over minus 7, multiplied by the adjoint. What's the adjoint?
1, 1, and then negative 4, negative 2.
Very good, negative 4 and negative 2. Nice. It says hence or otherwise we're supposed to solve this one. Now usually what you're solving end up to be like you just have x and y, but this have 4 unknowns, don't it?
Mm-hmm.
Look a little bit different, but it's the same procedure, but you're gonna see what's gonna happen afterwards. It's the same thing where we have M times our unknown matrix X is equal to the result matrix R. So we know how to find X already. X is just going to be, X will be M inverse times
the
times
but
R.
oh, like the result, yeah.
Yeah. That's all we do. So X, this unknown matrix is the same as any M inverse times R. So you're wondering, let's see what's going to be the big difference. First, let's write down back what they had. They gave us M, and M was 1, 4, 2, 1. This was M. And then we found M inverse. Now we're just writing down back what we found. M inverse we found to be 1 over negative 7. And this was multiplied by 1, 1, negative 4, negative 2. All right, now let's write down back the product of the matrices that we have. This is 1, 4, 2, 1, A, B, C, D, 4, 13, 8, 5. So this was 1, 4, 2, 1, multiplied by A, B, C, D, and that is giving us a result matrix of, difficult to remember, let's look back one last time. That's 4, 13, 8, 5. 4, 13, 8, and 5. All right, now let's go, Brianna. We're gonna solve this together quite easily. So now what you're gonna do is, we know how A, B, C, D is. A, B, C, D is M inverse times this matrix. So
Yes,
it's just going to be, this is M inverse, 1 over minus 7. And we have 1 minus 4 minus 2, 1. And that is then being multiplied by the result matrix right here. 4, 13, 8, and 5. All right, nice. So now when we multiply them, what we're going to get is 1 over minus 7 times, we're going to multiply these two matrices first. So we go row by column, So it's going to be 1 times 4, which is 4, plus minus 7, minus 4 times 8, which is minus 32, right?
Yes, sir.
That will give us the first element there. Now this one right here is going to be row by column. It's going to be 1 times 13, which is 13. Then we have minus 4 times 5, which is that, what is that?
-20.
Negative 20. All right, negative 20. Thank you. And then row by column, we have minus 2 times 4, that's minus 8. And then we have 1 times 8, which is plus 8, right?
Yes, sir.
And then finally over here, we have row by column, minus 2 times 13, that's minus 26, plus 1 times 5, which is 5. So now all I have to do now is we're going to continue up here just for space, but let's just switch pages. So continuing right here, this works out to be equal to minus 1 over 7 times 4 minus 32, that's negative 28, right? 4 minus 32.
Oh,
And,
yes, sir. Yes, sir.
and then the 13 minus 20, that's negative 7, right?
Yes, sir.
And then minus 8 plus 8 is 0.
0.
And this is negative 21, right?
Yes, sir.
Good. So this now, we can multiply each element by negative 1 over 7. So this is negative 28 over negative 7.
That's
That's
4.
4. Good. Then this is
1.
1. This is
0.
good. And this is
3.
3. Good, good, good. But remember, this was what? A, B, C, D, though.
Yes, sir.
Very good. So you see the trick now? It's just a 2 by 2. It's not even really a trick, right? It's just different. Usually it's just X and Y.
Yes,
So now we
sir.
could conclude that A equal
4.
very good, equating corresponding elements. B equal
1.
good, and C equal
0.
very good, and D equal
3.
D equal 3. All right, nice. So we can of course copy it and put it back to the front page just so it looks proper. All right, that's that. So that's all it worked out to be. That's A, that's B, that's C, that's D. All right, I think number 5 of something